Okay, year one IB. We're going to start chapter 3, E. This is 3E. We're going to talk about representing data, large groups of data, and saying, hey, do I really want to use all this data, or is there a better way, maybe, of taking this data and shrinking it down and still make some use out of it? And so to do that, we got to know some terms here. We got to know what a sample is. A sample of a data is a small group of the data, so it's not everything. And there's actually a couple different ways to do that. And so the sample is always taken from the population, which is the whole entire group, everybody's choice. So if you say, hey, in the classroom, what's your favorite ice cream? Everybody in the classroom would be considered the population. A sample size would be, taking a few of those people and saying, hey, what were your favorites? Just the boys, or just the girls, or just the people who have a last name that starts with a K. That would be a sample size. So there's two different choices, main choices for our samples, and that's a simple random, and random means obviously it's random. So it's not chosen with any specific things in mind. You just kind of grab in and say, you people, come with me. We're going to ask, what's your favorite ice creams? The other one, systematic, would be, hey, everybody who's the boys or the girls or those last names with a K, or every other person, to kind of say, what is your favorite ice cream? So that would be a systematic sampling. And so what we're going to do is the investigation here, and we're basing all of this information. I'm not going to click on the whole entire data here, but we're going to go through all of this, talk through these problems as if the data was in front of us. In the first problem there, it just wants you to find the mean number of airports from the table. You guys should be able to put that on your calculator in a list, and then go to single variable stats, and you should be able to figure that out. But as we start to go through here, and we're using this, it says, which of the following methods do you think will give you a random sample using the spreadsheet or your graphing calculator device, graphing device calculator? Find the mean in each case and give a reason why you think or does and not to give a random sample. So we're not even going to find what it is, because to find what they are is to actually put your plan in action. So if you said take every other country, then therefore you would take the values of every other country, and then you can plug it onto a new list and find it. So if you took the first 50 countries, which type of sample do you think this is? So remember, we're doing either systematic or we're doing a random. That's an interesting one, isn't it? And then, is this a good way? If we had, we're talking about a large sum of countries. Now, I quickly looked at that list, and the list actually is not in alphabetical order. So if, we're looking at that, then, maybe choosing the first 50 would actually be a random sample. But the list, has the country here, and then it has the number of airports. Well, they're actually listed as the most to the lowest. So that's why they're not in alphabetical order. So in this case, if I take the first 50 countries, that definitely is not going to be a random, because you're taking the top 50 countries of airport that has airports. So I don't think that would definitely be a very good random at all. So that would be very systematic. You're taking the ones with the most. If I take the top 25 and the bottom 25, which part B is asking, you think this is a good representation for the average? I think that could. Looking at the list, the top 25 probably have the most of all the countries combined, and then the bottom 25 almost have nothing. So I think that would actually work out really well for this, because for every one that's super big, many airports, it'll cancel one out here and kind of average and kind of go towards the middle, which would then be kind of the average. taking every fifth country, I think that would definitely be a good representation in a way, because you are again kind of weeding out a few of them, but yet you're still taking a sampling space across the whole group. So I think that would definitely be good for the mean. And then part E, though, if you put all the names of the countries into a hat and pick out 50 countries at random, I think that definitely would be a random sample, because you're just going to get a little bit of everything. And obviously, whatever countries you pick out could change the mean up or down, considering what they do. And then even F, even ask your friends which country they are from and use those countries. I think that still could be fairly random, but yet also systematic, because if you think about it, friends that we have in class or the friends that you have in school, we're all pretty much from the same place. So to find 50 friends from 50 different areas, at least not, face-to-face friends, I think that'd be pretty hard. Here we go in part 3. It says, which methods in part 2 do you think you give the most reliable estimates of the population? I think, the estimates for estimate, I think the ones at the top 25, the bottom 25 together, and the one that went every other, every fifth country, I think that could be. And then how do you know if your data is biased or not? I think if you were to, ask people, interjecting like where they're from, things like that, you could have some bias in there of, which countries, like, we're all from the United States, or we're all from, United States, Canada, or Mexico. So those would come up a lot more than, say, countries maybe in Europe. So that would be something you have to think of. What is bias data, I guess? If you're looking at number 5 there, it's asking us what's bias data. Bias data, I think, would be data that you kind of tend to lean towards or favor, right? Bias means to be favoring something, or favor or against something. And, can that be a reliable result? I think anytime that you start to throw your bias towards something, it kind of, makes everybody else leery about the validity, I'm messing that word up, of your results. And if you think somebody's data is being biased towards something, like drug companies who are saying, oh, my drug is great or not great, or things like that, or oil companies want to put a pipeline through your backyard, oh, it's going to be perfectly fine, we're safe. And then you got the other side, says, oh, no, you guys got a track record that's not so great. So you guys got to kind of take who's making this graph, who's making this data, who's presenting the information to you. If it's a double blind, or people who do run the experiment don't know that they're doing it, the people in the experiment don't know which part of the experiment they're in, that makes it a little bit easier to make it unbiased and be more reliable. So then we have this idea of convenience sampling, is that by getting data by selecting people who are easy to reach. Obviously, if I'm going to phone call people for a survey, the ones that answer the phone are a lot easier to get information from. Or even when, like next year when you guys start to do your IAs, you guys will be going and hitting up your fellow classmates to fill out some forms about how much they sleep they may get, or what kind of grades they have, things like that. And that is not necessarily a random sample of participants, because and so that could be biased because you're talking about students in your same socioeconomic background as you. So a biased sample is one that is not random, so that's interesting, right? So it's not random, you're searching your examples, researching spending habits on cars, and only interviewing people, exiting a garage. Well, that kind of makes sense. It'd make it easier to say, hey, who would you vote for? If you're hitting them on the way out of their polling station. But it makes sense to do some things like that. So sometimes it makes sense to be biased, and sometimes it's not. So we're given this table now, and it wants us to talk about this. I would highly suggest that you take the time, put all of those numbers onto your list, and then you can find the average of the IQs. So add them all up, divide by 200. and then find the mean of the first 20 and the last 20 members, and then read through here. I'm not going to go through everything, but then kind of talking about what we were doing before. Does that affect the mean? Does not affect the mean? What if I take every fifth person, fifth IQ? Does that change the mean? Comment on how, if I presented this data, when I change things like that. So these are all these people. I got some really smart people, right? I got some people that maybe not so not so bright, but the average is in here somewhere, right? Of all the people. And if I say I want to test the top, bottom, and the top, and all those things, can I change my data, make it look good, make it look bad? Randomly select them people. So quota sampling is setting certain quotas for your sample. For example, selecting a sample of 8 boys and 8 girls. So therefore, a lot of these terms kind of make sense. Random sample, being random, using the words that you're defining in the word. Quotas, having a certain amount of something. So if you're going to say, I need to poll 100 people to get, find out their favorite ice cream. Well, now I got a quota on there versus just saying how many can I get. I think you would understand that the more participants, the more sample, more population you have, the better results you will get, and things like that. So you can read through that, and then that's called, it's not random because you're telling people that you have to have this many of this, and then it says that it can be biased and it can be unreliable because if there are more boys or girls in a certain thing that do certain things, then why would you include equal amounts of each? So that could be something to look into, and it says that it could be inexpensive this way, easy to perform, saves a lot of time, but there is more reliable than convenient sampling where people are selected based on availability and may not be representative of the population. So everything's got its ups and downs. So be very careful on that. And so you got stratified sampling. It's a sampling of random people where numbers in certain categories are proportional to their numbers in the population. Now this actually is something that I think we all try to strive for, at least in polling data, right? You hit the exit polls, how many people are in Wisconsin, or how many people of a certain race voting for certain not constituents, that's the other way around, they are constituents, voting for certain people and running for an office. And so, it kind of for the Senate or Congress and all those things, that your representatives are proportional to the amount of population, the census that's coming up. That's why that's important. So the more people that you have in a certain area, they should have more weight and pull towards, that particular data. So stratified sampling just means that if, boys make up 40% of the class, then you should poll, 40% of your poll should be made up of boys. And that kind of makes sense. And you can go through the example there and kind of shows, is it kind of see, are they making a stratified? Are they doing things correct? We're going to skip this, but you can do this one on your own. Just making sure you can talk about, how you organize and finding the averages again. And is it biased or unbiased? Here's your homework, 3E. And there's the other page. Have a great day.